Welcome friends. In the last lectures, we have discussed about the short transmission line and its various aspects. Now, in few subsequent lectures, we will discuss about the medium transmission line and long transmission line. What is the difference between them? First of all, medium transmission line is spanning between 100 to 250 kilometer long, and it mainly analyzed using lumped parameter model. And long transmission lines are spanning above 250 kilometer line, and it is analyzed using distributed parameter model, although it is seen in many literature that lumped parameter models has been used successfully for long transmission lines. So those results are fairly acceptable. Medium transmission line with lumped parameter model can also be considered as long transmission lines with lumped parameter model. So today we shall first see medium transmission line. That is, we have two lumped parameter models. First one is T representation. Subsequent to that, we will discuss pi representation, and then we shall see a numerical problem on medium transmission line, and after that we shall see long transmission line and its analysis. So we are starting medium transmission line. We starting our topic today, that is medium transmission line. It is ranging from 100 to 250 kilometer roughly, and using lumped parameter model. So let us first discuss equivalent T representation. Equivalent T representation. Let us first discuss that. Now, if you draw the equivalent T representation, what is that? The entire impedance of the network has been split into two parts, each Z by 2. So this is Z by 2. This is also Z by 2. And in between of the line, we have shunt admittance. We have shunt admittance Y. So we have sending end here, Vs as our sending end voltage and Is as our sending end current. We have receiving end, we have Vr as our receiving end voltage and IR as our receiving end current. So we know our famous equation, Vs is equal to AVR plus BIR, and Is is equal to CVR plus DIR. So we shall quickly see what is the value of ABCD parameters in case of this T representation. So let me explore, let me write some equations. Now write down the first KVL equations. First KVL equation we write, what is Vs? Vs is equal to Is into Z by 2, that means this drop, plus IR into Z by 2 This corresponds to this drop plus VR. We have Vs equal to this. Okay. So this again now what is IS? IS is nothing but this current and plus this IR. Okay. So what is this current? Let me consider this node as X. So if I say this current is IC, current flowing through the shunt admittance is IC. So IC is written as Vx into Y. IS can be written as Vx into Y. That is the voltage at node X into shunt admittance plus IR. This is the value of IS. So let me substitute that. So IS is equal to Vx into Y plus IR, that whole multiplied with Z by 2 plus IR into Z by 2 plus VR. Again, what is Vx? Very important. What is Vx? This voltage. What is Vx? Vx is nothing but this drop plus VR. So this drop means IR into Z by 2, IR into Z by 2 plus VR. So that we substitute. So Vx, so if you write Vx is equal to IR into Z by 2 plus VR, so that is Vx, and that multiplied with Yz by 2, that multiplied with Yz by 2, right? Then remaining terms are, this term will yield IR into Z by 2, this term will yield IR by Z by 2, so altogether these two will make IR into Z. These two will make IR into Z plus VR. So now if you take VR common, so here we have Yz by 2, 1, and here you have 1. So if you take VR common, so first term you will get 1 plus Yz by 2 into VR. The next term comes, if you take IR common, so we have here 1Z, and here you have Z by 2 into Yz by 2. So ZIR if you take common, so we have 1 plus 1 from here, and another, and you have Yz by 4. So we get Vs is equal to 1 plus Yz by 2 plus we get Vs is equal to 1 plus Yz by 2 into VR, and Z into IR into 1 plus Yz by 4. So comparing this, so we get, comparing these two, we get A is equal to 1 plus Yz by 2, and B is equal to Z into 1 plus Yz by 4. So this is AB for you, for T representation. So now let us coming to C and D. What is C and D? You see, IS is already calculated or written Vx into Y plus IR. What is Vx? Vx is equal to IR into Z by 2. Yes, this is Vx. So Vx can be written as IR into Z by 2 plus VR, that whole multiplied with Y plus IR, right? So if you take VR common, so VR is only one term, so it is Y into VR, no issue with that. Now if you take Y, if you take IR common, so it will be 1 plus YZ by 2, 1 plus YZ by 2 into IR. So this is the equation of IS is equal to CVR plus DIR. So you get C is equal to Y and D is equal to 1 plus YZ by 2. So we have evaluated A is equal to 1 plus YZ by 2, B is equal to Z multiplied by 1 plus YZ by 4, C is equal to Y and D is equal to 1 plus YZ by 2. So this is the equivalent T representation. Now we will going to the second component, that is equivalent Y representation. What is the equivalent circuit? We can draw. Here impedance is not split. Impedance is not split, it is Z. However, the admittance is split into two parts. One part is called Y by 2 and another part is called Y by 2. We have sending end, this is Vs, sending end voltage, this is sending end current Is, we have receiving end voltage Vr, receiving end current IR, this is Z for you series impedance, and shunt admittance is Y by 2 each. This is Y by 2, this is also Y by 2. Let me use some let us say this current, let us say IC1. Let us say this current is IC1 and this current, let us say IC2. And let us say this current through the impedance is IX. So we can quickly write down some standard equations for this circuit. First we can write that is sending end current Is, that is equal to IC1 plus Ix. Again Ix is equal to IC2 plus IR. So from there we can write Is, that is equals to IC1 plus IC2 plus IR. What is IC1 is equal to? IC1 is equal to, you see this Vs voltage, this sending end voltage will fall directly on the shunt admittance. So IC1 is equal to Vs into Y by 2. IC2, this IC2 will be equal to VR, for similar reason VR into Y by 2 plus IR. Now what is Vs? Vs is equal to What is Vs? Vs is equal to this drop Ix into Z. Vs is equal to Ix into Z plus Vr. Ix plus Z into Vr. Right? So what is Ix? Ix is equal to IC2 plus IR that multiplied with Z plus VR. So IC2 means VR into Y by 2, VR into Y by 2 plus IR Z plus VR. So we can write, so Vs is equal to, so from here Vs equal to, we can write VR into Y by 2 plus IR that whole multiplied by Z plus VR. So this is total is equal to Vs that multiplied with Y by 2 plus VR into Y by 2 plus IR. So now if you search, we have, let me pick one by one. So we have here with Y by 2, ZY by 2, sorry, Z is outside, so ZY by 2. So we have one VR here, so it is Y by 2, and we have another VR here. So if you can take Y by 2 VR common, Y by 2 VR common, so we will get one from here, and we shall get another from here, and we will get from here, it is, I think it will be only Z. Right? I think it will be ZY by 2. ZY by 2. YZ by 2. Let me do one more time. So we have here with this Y by 2 into Y by 2, this term, and plus Y by 2 with this, of course, with the Z here, ZY by 2 into Y by 2 plus Y by 2 into VR plus Y by 2 into VR. That's done. And if you come with IR, so we have this is 1, and here we have Y plus, this will be the expression. So if you solve this, these two will make YVR. Right? These two will make YVR. So YVR, so this will, I think, so if you take Y common, YVR common, so it will be 1 plus, this will make 1, and this will make YVR, if you take this, so YZ by 4. So IS is given by this expression. So now if you compare, So now if you compare, it can be understood that C is equal to y into 1 plus yz by 4 and D is equal to 1 plus yz by 2. Now again, let me back with this equation. What was that? Vs is equal to VR into y by 2, VR into y by 2 plus IR into Z plus VR. So if you take VR common, so it will be 1 plus yz by 2 plus z into IR. So if you compare this, we will get A is equal to 1 plus yz by 2 and B is equal to z. So we evaluated ABCD parameters for pi representation as well. A is equal to 1 plus yz by 2, B is equal to z, C is equal to y into 1 plus yz by 4 and D is equal to 1 plus yz by 2. So we have seen the ABCD parameter evaluation process for pi representation and T representation network, that both represents the lumped parameter model of a medium transmission line. So with this, I am stopping here. In the next lecture, we shall demonstrate a problem on medium transmission line by which we will evaluate some important parameters. Thank you.